Hello and welcome to the MathematicsKicker. Today we are going to prove a theorem which states that a line drawn from a center of a circle perpendicular to a chord bisects a chord. In this case, something of this nature, we have a line which is drawn from a center of a circle. It is perpendicular to a chord, but we want to prove a theorem. We want to prove that AC is equal to BC. It means by proving that, we are proving that a line drawn from a center of a circle which is perpendicular to a chord. This is a chord, as we said in the introduction lesson, right? A line drawn from the center of a circle perpendicular to a chord, we can see is 90 degrees. It bisects the chord. It means that AC is equal to BC. We are required to prove that. We are required to prove this theorem, which states that the line drawn from a center of a circle perpendicular to a chord bisects a chord. Then how do we prove this type of a theorem? We are going to prove this type of a theorem, right? And first thing first, we have RTP. We are required to prove that RTP. We are required to prove that AC is equaling to BC. We are required to prove this theorem, right? Then how do we prove this theorem? We are going to construct. We are going to construct what? Construct O to A and what? And O to B, right? We are going to construct O to A. This is our construction. This is our construction. Then we constructed them. Then, after we have constructed, we're gonna mark, here we mark C1 and C2. Then we mark C1 and C2. I've marked C1 and C2, right? Then I've done that. Then now we are going to say that in triangle OAC and triangle OBC, right? In triangle OAC and triangle OBC, right? OBC. I said in triangle OAC, this triangle OAC and triangle OBC, right? We have these conditions. Actually, we are constructed O to A and O to B. It means OA is equaling to OB. Remember, in the introduction, when you prove, you have to give the reasons, right? Remember, in the introduction lesson, we said that a line drawn from the center of a circle to the circumference is a radius. Then it means this is radius, this is radius. You see, your answer will be equal radii. It means equal radius. You have two radius, right? And another thing, OC is equal to OC for both triangle, for OAC and triangle OBC. OC is equal to OC. OC is equal to OC. That is a common side. They share this side, it's common, right? You say the common side, right? You say common side. Then now again, C1 is equal to C2 and they're also equal to 90 degrees. This one is already given, right? It's already given because in the statement we are given what? We are given a circle with center O. We're given a circle with center O and what? And then we have 90 degrees there. Then we just constructed that, right? We just constructed AO and what? And BO, right? Or OA or OB, right? Then in this case, angles what? Angle C1 is equal to angle C2, right? Those are the sides. This is angle C1 to angle C2 is equal to 90 degrees. This one is given. To prove this theorem, we need to apply the properties of congruency. That is why in the introduction lesson I said know the types of triangles. When we study about the type of triangles, you will study about the congruency. You know about the congruency. Right, in this case, we can conclude by saying that triangle OAC, check the way I pick it. Triangle what? Triangle OAC and triangle what? OBC. Like OAC and OBC. We can say what? Triangle OAC is what? Is congruent. triangle OAC is congruent to triangle OBC. Said triangle OAC is congruent to triangle OBC. The reason is what? We have the side and the side, and we have what? We have the angle. It means we have angle side. But this one, the angle is 90 degrees. Is given a special condition in the properties of congruence. It's RHS. Here's the reason is RHS is a property of congruence. It's RHS. It's a right hypotenuse side. Its right hypotenuse is one of the properties of congruence. Right, because we have angle of 90 degrees and they share this common side and they also have equal radius. Right. It means two sides are equal and the angle of 90 degrees. That's why we said right HS is the right hypotenuse side. Then in this case, we can conclude, we are asked to prove that AC is equal to BC. We can conclude that AC, in this case, AC is what? Is equal to, we can say therefore, AC from here, from the congruence is equal to what? BC is equal to BC. This is AC equal to BC. Also, OC is equal to OC. Also what? OA is equal to OB. You can check it. Also what? CO is equal to what? CO. Then we can conclude by saying that therefore it is proven. Then Carl Gauss once said, it is not knowledge but the act of learning, not possession but the act of getting there, which grants the greatest enjoyment. I say peace. I'll see you on the next video. Thank you.